One of the most anticipated astronomical events is the Betelgeuse supernova. Located on the famous shoulder of Orion, Betelgeuse is a red supergiant star nearing the conclusion of its life. Strangely, in 2019, Betelgeuse, one of the brightest stars in the sky, began to fade. The dimming was so noticeable that it could be seen even without special optics. For a few months, Betelgeuse continued to dim, leading observers to wonder if the star had died. When scientists focused their most powerful telescopes on the red giant, they were shocked to see evidence of this great dimming. Even though the star's brightness returned to normal after a few months, the event signaled that this star is nearing the end of its life cycle and could explode as a supernova. But when and why might this happen? And will it have disastrous consequences for Earth? The brilliant ruby-red star Betelgeuse is located in the upper right shoulder of the winter constellation Orion the Hunter. It is also known by its alternative name Alpha Orionis and is the second brightest star in that constellation, directly behind the blue supergiant Rigel. Betelgeuse is a fascinating target for astronomers because of its variable behavior and peculiar name. Though alpha stars are typically the brightest in their constellations, Rigel outshines Betelgeuse. Nonetheless, Betelgeuse is one of the most famous stars in the sky. It ranks as the 10th brightest star in the sky and the 7th brightest visible from most of North America, Europe, and Canada. The name Betelgeuse comes from an Arabic phrase meaning the armpit of the giant, referring to its location in Orion. The actual distance of Betelgeuse from Earth is uncertain, but scientists estimate it to be between 430 and 724 light-years away. Simply put, Betelgeuse is the brightest and closest red supergiant star to Earth. There are only about 200 red giant superstars known in the Milky Way. Betelgeuse is 16 times the mass of the Sun and emits approximately 126,000 times more light. It is visible from a distance of about 548 light-years. Cooler than the Sun, Betelgeuse has a surface temperature of roughly 3,600 Kelvin. Only about 13% of its total radiant energy is emitted as visible light. If we could perceive all wavelengths, Betelgeuse would appear more luminous than Sirius. Betelgeuse is estimated to be about 764 times the Sun's radius in diameter. If Betelgeuse were placed in the center of our solar system, it would engulf Mercury, Venus, Earth, and Mars, reaching beyond Jupiter's orbit. As a red supergiant, it loses about one solar mass every 10,000 years due to uneven material ejection, creating a surrounding nebula. This nebula extends roughly 30 astronomical units, AU, or 30 times the distance between Earth and the Sun, and is about 250 times larger than the star itself. At the star's core, hydrogen atoms fuse into helium due to gravitational pressure, releasing energy in the form of heat and light. This energy travels to the surface and is emitted as photons. Eventually, the star exhausts its hydrogen fuel and begins fusing helium and carbon. When helium is depleted, neon interacts with carbon to produce iron. The fusion of neon and iron absorbs more energy than it releases, leading to a core collapse under the star's immense gravity. This collapse triggers a supernova explosion with the power of 10 billion suns. Stars emit light in different wavelengths and temperatures depending on their age and evolutionary stage. This gives rise to a spectrum of colors, from the blue of younger stars to the red of older ones. The Greek astronomer Ptolemy described Betelgeuse as ruddiness in color, but ancient Chinese records noted it as yellow, suggesting it may have once been a yellow supergiant. Massive stars burn through hydrogen quickly and may live only around 10 million years. Betelgeuse is unquestionably in its late stages, while our Sun, at over 5 billion years old, is still midlife. While Betelgeuse is nearing the end of its life and may go supernova, the exact timing is highly debated. The star has two known cycles of dimming and brightening. One of these occurs every 5 years and lasts about 100 days. These cycles are thought to result from the expansion and contraction of the outer layers, changing the star's diameter and temperature. Betelgeuse's unusual dimming in 2019 and 2020, followed by a brief return to normal brightness, led some astronomers to speculate that the star could be dying. The study of Betelgeuse dates back to the 1st century BCE. Despite extensive research, the cause of its sudden dimming remains unclear. After being ejected from the Orion-OB1 association, which includes the stars of Orion's belt, Betelgeuse was observed moving through the interstellar medium at 30 km/s. The bow shock from this high-speed movement stretches over 4 light-years. Calculating the exact distance and size of red supergiants like Betelgeuse is notoriously difficult. Its pulsing behavior and phenomena like limb darkening, which causes the star's edges to appear dimmer than its center, complicate measurement. Additionally, the circumstellar envelope composed of ejected material affects light emission and absorption, making direct comparisons between observations challenging. Diameter measurements can vary up to 35%, depending on the wavelength used. In July 2009, the European Southern Observatory released images from the Very Large Telescope Interferometer, VLTI, showing a massive gas plume extending 30 AU into space from Betelgeuse. This was one of several observed mass ejections. Astronomers have identified at least 6 such shells surrounding the star. Understanding the mechanism of mass loss in red supergiants is key to uncovering the mysteries of their final stages. Recent advancements in interferometry have provided better tools to study these phenomena. In 2019, astronomers using the Hubble Space Telescope and others discovered that Betelgeuse had ejected a significant portion of its visible surface, resulting in a major surface mass ejection, SME. This event expelled about 400 billion times more mass than a typical solar coronal mass ejection, CME. This SME led to Betelgeuse's rapid dimming starting in October 2019, which reached its lowest point in mid-February 2020, with its brightness dropping from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had stabilized for more than a week, effectively ending the dimming event. Infrared observations showed no significant changes, indicating the fading was not caused by an imminent core collapse. Another study published on February 24, 2020, suggested that large-grain circumstellar dust likely contributed to the dimming. Though sub-millimeter measurements ruled out dust absorption as a primary factor, large star spots may have also played a role. Further analysis revealed that Betelgeuse's luminosity had dramatically increased. In August 2020, a second dust cloud was discovered, possibly originating from a cold area on the star's photosphere identified in June of that year. It's believed that ejected gas cooled and formed dust, obscuring the star from view. The E-2022 Hubble data supported this theory, showing that the material ejected millions of kilometers from the surface cooled and compacted into dust. This obscured the star's photosphere, a layer several times more massive than our moon, causing the noticeable dimming. This dimming was visible even to amateur stargazers. Remarkably, the supergiant's regular pulsation cycle, which had lasted 400 days, ceased. Astronomers who had monitored Betelgeuse's surface activity and brightness variations for over a century believed the disturbance was caused by internal structural vibrations. The photosphere is now regaining strength, and the star behaves like a bell that's been cracked, disrupting its natural rhythm. These findings are crucial to understanding how red supergiants lose mass before exploding as supernovae. The fate of such stars depends on how much mass they lose in the final stages of life. Betelgeuse's unusual behavior doesn't necessarily mean an explosion is imminent. In fact, no similar surface mass ejection had ever been observed in a star before, suggesting that our understanding is still incomplete. With advanced telescopes like Hubble, astronomers can now observe surface features and real-time stellar events. The James Webb Space Telescope may soon detect the lingering infrared radiation from the 2019 ejection. As of now, Betelgeuse's dimming has ended, and it may once again shine as the 10th brightest star in the night sky. Despite its vast distance, Betelgeuse remains one of the sky's most luminous stars, shining nearly 100,000 times brighter than the Sun. Maintaining such brilliance requires rapid fuel consumption, which hastens its eventual demise. When the fuel runs out and the core collapses, Betelgeuse will explode in a supernova. For several weeks or months it could shine as brightly as the full moon and be visible during the day. So, when will this happen? We don't know. It could be tomorrow or it could be a million years from now. Will Earth be affected? Fortunately, Betelgeuse is far enough away, more than 10 times the safe distance of 50 light-years, for its explosion to have no harmful effects on life here. Instead, when it finally goes supernova, Earth will witness an extraordinary celestial event, a brilliant new point of light lighting up the sky.